Hi everyone, I'm going to talk you through the pre-lab for the Hess's Law. Okay, now give you a little bit of a checklist, right? So number one, of course, download lab, and that's at the Canvas lab site. Okay, so go to the Canvas lab site, download this experiment, and lo and behold, there it is. Okay, now number two, make sure you watch the video about Thermo Chemistry. Okay, so watch Thermo Chem video, i.e. the one I made, right? Okay, that'll give you all the kind of knowledge you need to answer the questions. Okay, so that's kind of super important. Everything you need is in that video. Get through that. This hopefully will be straightforward. Okay, and then number three, well, we'll kind of meet it as we go through. You actually have to kind of go online to a different website. I'll point out the address in a moment. Okay, and you do the virtual lab online. Okay, and you just basically follow the instructions. So let's just take a look through. Okay, so there is a pre-lab exercise. Okay, now if you've watched the Thermo Chemistry video, I talked about Hess's law of heat summation. This is exactly that. Okay, so all you got to do is add two of these equations. I'm not going to tell you which two, you have to figure it out, right? So add two of these equations to find the third, okay? And then put that down here, okay? You'll need this a little bit later on, okay? So, I will collect that. So, which of these two when added together, make the third, okay? You got to play around a little bit, okay? All right, now as you go through, so you have to go to the virtual lab site, okay, and there it is written right there, okay? So Chem Collective, okay? Sounds a bit Star Trek. That's a joke, right? Okay. So go to this site, and then you'll kind of follow these instructions through. Okay, these tell you exactly what to do with the software you actually kind of look at this site. Okay, so you open the site, you follow these instructions. Essentially, it's like doing the experiment. Okay, so you do a couple of reactions, and if you want to kind of a little bit of a heads up on that, if you remember when you see it in the Thermo Chemistry packet, I talk about the coffee cup calorimeter, and we actually do a worked example of acid plus base on that one. So you'll see how that, when we worked out kilojoules per mole, that's essentially what you're doing here, okay? So there's a very, very good practice example in the notes, okay? So basically you do that variation on a theme, you do that practice example like 3 times, 3 different reactions, okay? We talked about this. This is the first law of thermodynamics, and the Q in the first law of thermodynamics comes from calorimetry. So we've talked about this before. Follow that through, and you'll be able to work out kilojoules per mole for those 3 reactions. Okay, all that's summarized in this last page here. Okay, so this last page, of course, is vital. Okay, as is, for clarity, this little first one here. Okay, so I don't mind if you give me the whole packet, but probably it's easier if you just give me this first page, this last page, and maybe a page of notes, of a page of work, right? So you got to show me how you get these things. Do a sample calculation. All right. So if we just look through this data sheet real quick, so you got masses of reactants, masses of solutions. So this gives us moles of a reactant, limiting reactant. That's just like the one in the packet. Mass of solution, remember M in Cp m delta T, Q equals Cp m delta T, that's the mass of solution, so you need that. Initial and final temperature to get delta T, okay? All right, Q, Cp m delta T, remember Cp is the heat capacity, which is the same as water, 4.184 joules per gram per degree C. Get a Q, if it's exothermic, Q is, you tell me, it's plus, right? Okay, so H, delta H would be minus, it's the same number, change the sign. Work out the moles from the mass, and work out the moles from the mass, and then delta H kilojoules per mole. Okay, now make sure you read the fine print in the lab packet for that. Okay, you can do a calculation with heats of formation. Okay, so if you get stuck, do the, take the accepted value as the heat of formation number. You can work that out. There's some examples on heats of formation. But I think, I'm thinking back to when I taught this face to face, I think in the fine print of the lab it was actually stated what to do with regard to referencing an accepted value. So just double check that. Okay, so 3 reactions. Okay, make sure you read the fine print. Those are those 3 reactions we saw in the packet there. Work it through, and honestly, not such a bad lab as long as you keep things straight. So very key, right? Make sure you go through that thermo packet in some detail, practice the questions, and then, it's the same math here. All right, hopefully that makes sense. Get this posted. It's kind of Tuesday afternoon. It's a little late this week because I spent the morning at the DMV. That was fun, right? But it's one of those weeks where we actually have just the 1 lab, so I'm actually going to be pretty generous. I won't, necessarily, do it as quick as you can, right? As quick as is comfortable, but I'm not going to make it required until Sunday, right? Why? Because there's only 1 lab this week, okay? So there's not another one you have to squeeze in. And 2, I want you to focus on your quiz. So on Thursday, right after office hour, I will be sending you your week 6 quiz, right? Okay, so make that week 6 quiz the priority. Get that done. It's great if you do the lab first. That's okay, but if you need to put the lab off, that's fine. Just concentrate on that quiz. Okay, so you might want to review for that quiz. Right. Okay. All right. So stop there. I'll post this as soon as I can. Any questions? Usual thing in the discussion for this particular lab or in the water cooler chat. Okay. See you on the next one.